All right, so solve each absolute value equation algebraically and then graph the solutions on a number line. So for this one, I'm just going to try and get x by itself and then all the other stuff on the other side. So we do the inverse operation like normal. The easiest thing to do first, I want to leave this absolute value bracket thing by itself. That's the last thing we deal with. So I'm going to move the 2 by subtracting 2. Whatever I do on one side of the equal sign, I do to the other. Why am I subtracting 2? Because in the original equation, we're adding 2. What's the opposite or inverse of adding? Subtracting. And whatever I do on one side, I got to do on the other. So 2 minus 2 is 0. 0 plus the absolute value of 3x is just the absolute value of 3x. And that's equal to 8 minus 2, which is 6. So now this is the interesting part about this. I'm going to have to divvy this up into 3x equals, well, let me back up. In order for this to equal 6, I should think in my head that the absolute value of negative 6 is equal to 6. And the absolute value of 6 is positive 6. So I have two possible solutions. In other words, 3x could equal 6, or 3x could equal negative 6, right? So I have to consider those two things. The stuff inside the absolute value brackets could be negative 6 or it could be positive 6. Yeah. So what we're going to do then is we're going to solve these two equations and have two solutions. And then we'll graph the solutions. So, by the way, did I say or? I did say or. So what does or mean? One or the other. Yeah, it could be one or the other, but we'll figure it out in a second. So 3x, so I'm going to divide by 3. Why? Because we're multiplying by 3 here. So we have to do the inverse, dividing both sides by 3. 3 divided by 3 equals 1. 1 times x is x. And then I've got 6 over 3, which reduces down to 2. Or x is equal to, if I do the same thing over here, negative 2. Now, those are the only two solutions that I can plug in, and that will equal 6. Now, if I graph this on the number line, because I don't have any inequalities yet, but this should be a straight number line. Are we including those values? Yes. So you could do it like this. X equals positive 2. Put a closed circle at positive 2. X equals negative 2. Put a closed circle at negative 2, and you're done. But on your handy-dandy calculator, we can actually solve this. So what I'm going to do is I'm going to change this, and I'm going to take the left-hand side of the equal sign, which is the absolute value of 3x plus 2, and then I'm going to graph the right-hand side of the equal sign and look to see where they intersect. Where do you suspect that they will intersect? 0. X equals 2 and negative 2. So let's see if we're right. So if I say the absolute value, I'm going to say math, go over to absolute value. If you have a calculator in your hands, you should be plugging this in. If you don't have a calculator, shame on you. Plus 2, right? Is that what the left-hand side was? Then I'm just going to graph the right-hand side of the equal sign. I'm just going to say 8. I'm going to make sure this is a line. So I'm going to hit enter, go down here, wait till I get to a line, and then hit enter. And I'm going to graph this. Now what I'm looking for is the intersection. My solution, in other words, this horizontal line, y equals 8, is when the y value equals 8. So where these two cross are the solutions to this equation. So let's see, if I hit trace and I plug in negative 2, what do you think the y value will be? 8. If I plug in 2, what do you think the y value will be? 8. That's it. Easy peasy, right? So I'm going to take a snapshot of that and plug that in the notes. So that's how you could use your graphing calculator to make sure that you've done the work correctly. Okay? Are there any questions on that? By the way, you can solve any equation on your calculator by graphing the left-hand side of the equal sign and the right-hand side of the equal sign and finding out where the graphs intersect. That one's free of charge. You're welcome.